everyone! Welcome back. Today, we're looking at sequential counting with loops. Up until now, if you wanted to count from 1 to 10, you might have thought about writing 10 different print statements. But as programmers, we like to keep things clean and efficient. That is where loops and the range function come in to automate the boring stuff for us. Let's break this down line by line. Look at line 1. It starts with the word for. In Python, a for loop is like telling the computer, hey, I want you to repeat a task multiple times. Right next to it, we have this little letter I. Think of I as a temporary variable or a storage box. Every time the loop runs, Python is going to automatically drop a new number into this box. Next, we see in range 1, 11. The range function is a built-in Python tool that generates a sequence of numbers. Inside the parentheses, we give it two numbers, a starting point and an ending point. Now, here is a golden rule in Python that trips up almost every beginner. The range function includes the starting number but stops just before the ending number. So, range 1, 11 tells Python, start counting at 1 and stop right before you hit 11. That means it generates the numbers 1 through 10. Finally, notice that colon symbol at the very end of the line. That colon is crucial. It tells Python, get ready, because the instructions for what to do during the loop are coming up next. Now, look at line 2. You'll notice it is pushed to the right. That space is called indentation, and it's how Python knows that this specific line belongs inside the loop. Inside the parentheses, we have our variable I. So, what happens when we run this? On the first round, Python grabs the first number from our range, which is 1, puts it into I, and prints it. On the second round, I becomes 2, and Python prints it. This keeps repeating like a wheel turning, all the way until I becomes 10 and prints it. Once it reaches 11, the loop realizes its job is done, hits the brakes, and stops. When you click Run, your console will instantly display the numbers 1 through 10 stacked neatly on top of each other. With just 2 simple lines of code, you've successfully automated a repetitive task. Pretty cool, right? Practice changing the numbers inside the range function to see how it behaves, and I'll see you in the next lesson. Hey everyone! Today, we're going to look at a super simple yet powerful way to find the largest number in a group using Python. Python actually has some amazing built-in tools that do the heavy lifting for us, so we don't have to write long, complicated logic. Let's break this down line by line. First up, we have a equals 15. What's happening here? Think of the letter T as a small, empty box. By using the single equals sign equal symbol, which we call the assignment operator, we are taking the number 15 and dropping it right into that box labeled the. So, whenever our program looks at it sees the number 15 inside. Right below that, we do the exact same thing for our second number. We create a new box, label it B, and assign the value 42 to it. Now, B is holding our second number. And to round out our data, we create a third box labeled C and store the number 23 inside it. So, right now, the computer is remembering 3 distinct variables, A, B, and C. Now, you'll notice this line starts with a hashtag or pound symbol, hash. In Python, this indicates a comment. The computer completely ignores this line when running the code. It's just a helpful note left by the programmer for the programmer to explain what the next line of code is about to do. Here is where the real magic happens. We are creating a brand new box called largest. To figure out what goes inside it, we call Python's built-in max function. Inside the parentheses, we feed it our 3 boxes, A, B, and C. The max function instantly looks at the values inside them: 15, 42, and 23, compares them behind the scenes, and picks out the biggest one, which is 42. It then takes that 42 and saves it into our largest variable. Finally, we want to see the result on our screen, so we use the print function. Inside the parentheses, we give it two things separated by a comma. First, a piece of text wrapped in quotation marks. The largest number is. Python will print that out exactly as it looks. Second, we give it our variable the largest. Python looks inside that box, grabs the number 42, and prints it right after the text. When you run this program, your screen will cleanly display the largest number is 42 foot dot. And just like that, in only a few lines of code, you've successfully found the maximum value. See how clean and readable Python is. Keep experimenting with different numbers, and I'll see you in the next lesson. Hey everyone! Today, we're going to look at a simple yet powerful Python program that calculates the area of a rectangle. If you're completely new to programming, don't worry, we are going to break this down line by line so you know exactly what the computer is doing at every step. Let's dive in. Let's start with the very first line of code. Here, we are creating something called a variable named length. Think of a variable as a labeled storage box inside the computer's memory where we can save information to use later. Inside this box, we want to store whatever the user types. To do that, we use the input function. The text inside the quotes, enter the length, is a prompt. It will show up on the screen to tell the user exactly what we want them to type. Now, notice how input is wrapped inside float. By default, Python reads everything a user types as plain text or at string. But you can't do math on text. So, float takes that text and converts it into a floating point number, which is just a fancy programming word for a number with a decimal point like 5.5 or 10.0. So, in short, this line asks the user for a number, turns it into a decimal, and stores it in our length box. The second line works exactly like the first one, but this time, we are creating a second storage box called width. Again, the computer prompts the user by printing enter the width on the screen, waits for them to type a number, converts that input into a decimal using float, and safely stores it away in our width variable. Now, our program successfully holds both pieces of information it needs to do some math. Next up, you'll see a line that starts with a hashtag or pound symbol, a hash. In Python, this is called a comment. Comments are completely ignored by the computer. When Python runs this code, it skips right over this line. Comments are just notes written by the programmer, for the programmer to explain what the code is doing. This one lets us know that the next step is going to use a multiplication formula to calculate the area. Now for the core math of our program. On this line, we create a third and final variable box named area to figure out what goes inside it. The computer looks at the right side of the equal sign. It goes into the memory, grabs the number we stored in length, and multiplies it by the number we stored in width. In Python, the asterisk symbol asterisk is used for multiplication. Once it multiplies those two numbers together, it saves the final answer right inside our area variable. Finally, we need to show the result to the user, and we do that using the print function. Inside the parentheses, we give it two things separated by a comma. First, a piece of text inside quotes, the area of the rectangle is. Python will display this text exactly as it is written. Second, we give it our area variable. Because area is not in quotes, Python knows we don't want to print the word area, we want to print the actual math result stored inside that box. The comma automatically puts a nice, clean space between our text and the final number when it displays on the screen. And that's it. In just 5 lines of code, you've learned how to take user input, convert data types, perform calculations, and display the results back to the screen. You're well on your way to mastering Python. Keep coding, and I'll see you in the next one. Hey everyone! Welcome! Today, we are going to look at a classic programming challenge: building an automated rocket countdown. This is the perfect way to understand how computers handle repetitive tasks using something called a while loop. Let's break it down line by line. We start right here on line 1. Think of count as a little digital storage box in programming. We call this a variable. Inside this box, we are dropping the number 5. This is our launchpad starting number. Every countdown needs a beginning, and ours starts at 5. Now we hit line 2, which introduces the while loop. You can think of a while loop like a security guard at a club gate. The guard asks a question: is the count currently greater than 0? Because our count is 5, the answer is a big yes, or true, as computers say. Because that condition is met, the guard opens the gate and lets the program step inside the loop to run the next lines of code. Once inside, the computer hits line 3, print and count. This simply tells the computer to shout out whatever number is currently hidden inside our count box and display it on the screen. Since we just started, it prints a clear, bold 5. Line 4 is where the magic happens. It says count equals count 1. Don't look at this like a math equation, look at it as an action. It tells the computer, take the current number in the box, 5, subtract 1 from it to get 4, and stuff that new number back into the box. Now, here is the secret of the while loop: it doesn't just keep moving forward to the next line of the script. It loops back up to our security guard on line 2. The guard asks again, is the count greater than 0? Well, now the count is 4. Is 4 greater than 0? Yes. So it prints 4, subtracts 1 to make it 3, and loops back up again. This repeating cycle keeps going. It prints 3, then 2, then 1. But what happens when count becomes 0? The program loops back to the top one last time. The guard asks, is 0 greater than 0? No, it's not. The condition becomes false. The guard closes the gate. The loop instantly breaks, and the program finally jumps completely past the indented code to the very last line. With the loop finished, the computer reaches the final line, which sits flat against the left margin. It executes print, blast off. The engines ignite, the text hits the screen, and our rocket takes off into space. And just like that, with only 5 lines of code, you've mastered the basics of automation and loops in Python. Happy coding! Hey there! Welcome! Today, we're going to look at a brilliant little Python program that counts the number of words in a sentence. It's an elegant, simple glimpse into how computers process everyday data. Let's break it down line by line. First up, we have line 1. Here, we create a variable named sentence. Think of a variable like a labeled storage box. Inside this box, we are going to store whatever the user types. We do this using Python's built-in input function. When the program runs, it will display the text type a sentence on the screen and blink, waiting patiently for you to type something in and hit enter. Whatever you type gets saved right inside our sentence box. Now for line 2, where the magic happens. We create a new storage box called words. Then, we take the sentence the user gave us and attach .split to it. What does .split do? By default, it acts like a pair of digital scissors. It looks at the sentence, finds all the empty spaces, and cuts the sentence at those spaces. It isolates every single word and groups them together into a neat list. So, if you type to I love Python, .split turns it into a collection of 3 separate items. I, love, and a Python the dot. Moving on to line 3. We need to know how many words we just found. We create another variable called word_count. To fill it, we use the len function, which is short for length. We pass our list of words into it. Python quickly counts up the total number of items sitting inside that list and hands back the number. If our list has 3 words, len simply outputs the number 3, and we save that number in word_count. Finally, line 4. This is where we share the results with the user. We use the print function to display a message on the screen. Notice how we mix regular text inside quotation marks with our word_count variable. Python smoothly glues them all together. So, instead of seeing the literal word or word_count, the computer looks inside that box and prints the actual number we calculated. The final output on your screen will say your sentence has 3 words. And just like that, in 4 simple lines, you've built a functional data processor. You took raw text, broke it apart, measured it, and communicated the result. Fantastic job. Keep experimenting, and I'll see you in the next one.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.